Good day, viewers. You are welcome back to class. As you already know, my name still remains Israel. Now, today's discussion, we are going to have a look at some vital areas that you may likely encounter in your Jamb. Please understand it properly. Settle down and understand it properly, because proper understanding of these topics will be able to assist you in the examination hall, even though the question may be twisted. The question says, define collision theory. By definition, proposes that for a reaction, just as the name applies, collision, collide, for a reaction to occur, the reactant particles must hit themselves. That is, they must collide with themselves. But remember, it's not all collisions that result in reactions. Only those collisions that have a certain amount of energy, called activation energy. Either the collision have an energy equal to the activation energy or greater than the activation energy before the reaction can occur. Therefore, according to the collision theory, it's only those collisions that have a certain amount of energy called activation energy, or the energy they have is more than the activation energy before the collision can occur. If the collision does not have energy equal to or greater than that energy they call activation energy, reaction will just bounce back and nothing happens. We never have products. So that kind of collision is known as effective collision. That is the collision that have a minimum amount of energy known as the activation energy, or the energy they have is bigger or greater than the activation energy. That is what they call collision theory. So when they have that kind of energy that supersedes or is equal to activation energy, reaction will occur and will now attain a certain height, which we call activation complex, before it can, because the activation complex is unstable, have a very high amount of energy, easily decompose into product. That is that on define collision theory. Define exothermic and endothermic reaction. And there are so many reactions you encounter where heat is released to the environment. You are just carrying out the reaction, maybe in the lab. You see heat is just being released. The thing become very hot. You know that kind of reaction is exothermic. So exothermic reaction is the reaction in which heat is released to the environment. Example is sulfur oxide reacting with oxygen to give you sulfur 6 oxide. So we put 2 here, put 3 here. 2SO2 plus O2, 3SO2. Or 2SO3, sorry. O3, because we are using this. So this is an equation for, and as an example of this kind of equation is occurs in exothermic reaction whereby heat is released. And to signify that heat has been released to the environment, you have your delta H negative, can be minus anything, kilojoule per mole. So this delta H or triangle H is known as the enthalpy change. H is enthalpy, the triangle means change, enthalpy change, or heat content of a reaction. Usually symbolizes or represents a reaction, the kind of reaction, whether it's exothermic or it's endothermic. When it is negative, it is known as exothermic reaction, means that heat is released to the environment. However, when it is positive, it means that heat is absorbed. That takes us the second part, endothermic reaction. And endothermic reaction, remember this one is exothermic. A reaction whereby heat is released to the environment. The container usually become hot. Then endothermic reaction is a reaction in which heat is absorbed from the environment. Heat is taken in from the environment. That is endothermic reaction. Example of such reaction, you have a decomposition. When you are decomposing anything, like the decomposition of hydrogen peroxide using manganese phosphate as a catalyst to prepare oxygen. If you remember that precisely, you know that it's preparation of oxygen. You see that heat is supplied to be able to break that hydrogen peroxide in order to produce oxygen. That kind of reaction is known as endothermic reaction because heat is absorbed from the environment. You have endothermic reaction. You have H2O2. This hydrogen peroxide to give you H2O plus O2. Let's see whether it's okay. No balance, 2H2O2. 2H2O plus O2. So this kind of reaction, enthalpy change, you write plus positive. Positive any value. It can be plus 2.5 or plus 10 kilojoule per mole. But the important thing is that it's positive. So this endothermic reaction, a reaction in which heat is absorbed from the environment. The important thing here you must notice this. Exothermic reaction is a reaction in which heat is released from the released to the environment. You have delta H equals negative. All those reactions you encounter during laboratory work, neutralization reaction, A to Z, all of them are forms of exothermic reaction because heat is released to the environment, while decomposition reaction is usually endothermic. So you can see this one is signified by positive charge. So that is for this. Draw the energy profile diagram for exothermic reaction, endothermic reaction. So having understood this, we can now draw energy profile diagram for both reactions. Energy profile diagram for exothermic, because they can draw it for you and tell you what kind of reaction is this. So you look at another question that may be asked, you encounter it, so look at it. That's number 3. Draw energy profile diagram for S1 exothermic reaction. To draw energy profile diagram, you start from the top. You see it goes to artificial complex, it goes down. You see it. So if you want to know it, this is, let's say this SO2, 2SO2 plus O2. You see it. This one reactant and this product 2SO3. You see it. These two react together to form this product 2SO3. Good. So you put a broken line here, or you can put a straight line from this place to this place is known as EA, activation energy. This activation energy. Then you see from here, from this place again to this place is known as delta H, and it's minus, it's negative. So this is the enthalpy. This change from here to here, you subtract it, you have enthalpy change, and the result is always negative. Why? Because heat is released to the environment when you undergo exothermic reaction. This side is known as energy or potential energy, is reaction part. So this is a simple exothermic reaction where heat is released to the environment. You can see from here to here is known as the activation energy. That is the energy that the reaction must overcome. That's the barrier that the reactants must overcome before it can attain the activated complex. This is known as activated complex. Is usually the place that have the highest energy. Don't forget that. It has the highest energy. Because it has a very high amount of energy, it is not stable. It's easily decomposed to give you this product. This kind of reaction is known as exothermic reaction. So let us draw another one here. B, endothermic reaction. We'll draw it small. You see it goes up. Remember, if you measure it, let's say this 2, 4, 6, 8, 10, 12. If you measure it, don't forget this. The heat content of product is always lesser than the heat content of reactants because it has given out some heat. So it now collapses and goes to lower energy. The heat content of product is less than that of reactant, or the heat content of reactant greater than that of product because bonds are usually broken and formed. So if you look at this one again, this is a simple endothermic reaction. Let me demarcate it. This is exo energy profile. Why this endothermic reaction? Endo. I'm not cleaning because I'll still use it. Endothermic reaction or energy profile. So if you look at it, this is the reactant, let's say H2O2, 2H2O2, to give you product 2H2O plus O2. This is the reaction part, and this is the potential energy. This is the potential energy, this is the reaction part. Now, if you look at it from here again, it goes straight to this place. It doesn't touch this one this time around. Move it from here to here. This is the activation energy. That's the minimum amount of energy which a reaction requires before it can occur. From here to this place is the triangle H, which is the enthalpy of the reaction, and it's positive plus. Now, if you look at it properly, let's say we are giving it values 2, 4, 6, 8. You can see this one maybe correspond to 6. Don't forget, these are what they may ask you. The energy of reactant is less than that of product because before you get to the product, you are accumulating energy. Nothing is allowed to lose. You are already only absorbing energy. So this is the energy profile diagram for endothermic reaction Delta H, which is the enthalpy, is positive. This one, enthalpy, is negative. Then the last one, what is the effect of catalyst? The effect of catalyst on the reaction. Remember, in a reaction, catalyst, in equilibrium reaction, actually, catalyst does not affect anything. The only thing catalyst does is this: it reduces the time equilibrium can be attained. That is all. The amount of product you are forming without a catalyst is the same amount of product you are going to form with a catalyst. The only difference is that a catalyst reduces the time by reducing the activation energy barrier. For example, this is the activation energy barrier from here to here, which must over. If you put a catalyst, this one will become EA, where EA is the original one. Catalyst, we put it like this. You see it? So from here to here is the barrier you must cross. Instead of crossing to this top, you now cross to this place. So this one will be EA2. This is the one for catalyst. You see, it has shortened the time where product will be formed. In this case, the same thing applies. You see it? Instead of getting to this place, you now have EA2 here. EA2, EA1. Catalyst is EA2, catalyzed reaction. Instead of getting to this top activated complex, you have this top activated complex. You may be told to subtract the activated complex of the original from the catalyst. You now deduct these two. Everything will be marked in your graph, in your computer. My friends, this is all we can take in this topic, but please kindly note it very well. Observe it, study it properly. You want to solve any questions that may come from this topic. Thank you very much, and God bless you. Don't forget, my good friends, kindly subscribe and share it. Thank you.